Hi everyone. So we're going to go through our Chapter 6 test review and hopefully we know how to do some of these things. And the test is going to be on Friday. So let's get started. First off, starting with trig. Find the exact values each of the given trig functions at the specific angle. So cosine of pi over 6, we can use a left-hand trick. Pi over 6, cosine is root 3 over 2 comma 1/2. So cosine is root 3 over 2. B, tangent of pi over 4. Tangent of pi over 4 is root 2 over 2 divided by root 2 over 2. So that's 1. Sine of 2 pi over 3. So that is the y value in the second quadrant. So 2 pi over 3, that's the high one. So that's root 3 over 2, because this point is negative 1/2 root 3 over 2. Cosine of 31 pi over 6. So I have to subtract 2 pi from that, which gives me the cosine of 2 pi is 12 over 6. So that 31 minus 12 is 19 pi over 6. So I have to subtract another 2 pi, because I don't know what that is. So if I subtract another 12 pi over 6, which is equivalent, I get the cosine of 19 minus 12 is 7 pi over 6. So then I go to my unit circle. 7 pi over 6 is right here. And that means the x is long, the y, so that means my x is negative root 3 over 2. Cosine of 1/2 is 1. Tangent of 3 pi over 2. That's down here, which means my x is 0, my y is negative 1, tangent is negative y over x, so I get undefined. Next up, convert 225 to radians. So in order to do this conversion, I'm going to multiply this by pi over 180 degrees. Now, if I simplify that, I get 5 pi over 4. Likewise, if I'm converting 5 pi over 4 into degrees, I multiply it by 180 over pi. Pi's cancel. 180 divided by 4 is 45. 45 times 5 is 225 degrees. Those are pretty straightforward. So, moving on. Convert 59 degrees, 45 minutes, 10 seconds to a decimal in degrees. So, this is where we grab our calculator. So, here's my calculator. I'm going to go to the home button, open a new document, add a calculator, and what I want to do is say 49 degrees, 45 minutes, 10 seconds. Well, I already know what 59 degrees plus there are 60 minutes in 1 degree plus 10 over, there are 3,600 seconds in a degree, or 3,600 seconds in an hour, if you want to think about it that way. So if I do on my calculator, which I'll zoom in just a little bit for you, I get 59 plus 45 divided by 60 plus 10 divided by 3,600, and I hit enter. I get 59.7528. 59.7528 degrees. Next up, zoom out just a little bit. If I'm converting to degrees, minutes, and seconds, I want to take 37 is my degrees. I'm going to multiply my decimal, 2.251 times 60, because there are 60 minutes in a degree. So if I do 0.251 times 60, I get 15.06. So I have 37 degrees, 15.06 minutes. So I'm going to take 0.06, I'm going to take this number and multiply that by 60. So if I type 0.06 times 60 in, I get 37 degrees, so that stays the same, 15 minutes, and 3.6 seconds. So if we were rounding to the nearest second, I could say 37 degrees, 15 minutes, and 4 seconds. Next up, find the length of the arc of a circle with a radius 3 meters and central angle of pi. Use the formula S equals r theta. So the arc length, which is the crust question, is just 3 times pi. So that is S equals 3 pi meters. Area. Find the area of a sector of the circle with radius 10 inches, central angle of 90 degrees using the formula A equals 1/2 r squared theta. Be sure to include units. The trick about this with a central angle, this needs to be in radians. So I need to multiply 90 degrees times pi over 180, which is pi over 2, in order to use this formula. So now I have A equals 1/2 r squared times pi over 2. So I get pi over 4 times 100, which is 25 pi inches squared. Would be my answer with the units. So there's the first page. Let's see what we have moving on. So next up, if I give you a point, find all 6 trig functions. So we know this is in the first quadrant. My point right here is 1/2 comma √3 over 2. Or another way of putting it is my x is 1/2, my y is √3 over 2. So what I need to find out is my hypotenuse for the first thing, which I kind of already know that this is going to be on the unit circle, but let's just prove it. I have 1/2 squared plus √3 over 2 squared equals c squared. So 1/2 squared is 1/4 plus √3 over 2 squared is 3/4 equals c squared. So c squared equals 1, so c equals 1. So this is on my unit circle. So I can just use my facts that I know that sine is the y value and cosine is the x value. So sine of theta is √3 over 2. Cosine of theta is 1 over 2. That's my x value. My tangent of theta is y over x. So √3 over 2 divided by 1/2. So I multiply by the reciprocal times 2 over 1. The 2's cancel, so the tangent is just the square root of 3. So reciprocal cosecant is 2 over √3, which is 2 √3 over 3. Secant is 2, and cotangent is 1 over √3, or √3 over 3. So if I can give you a point, you can find all 6 trig functions. The next section, we didn't quite go over using our calculator, so I don't expect you guys to have to do this portion. So we can just say skip. What we are going to do is focus on this just a little bit next chapter. So we'll see this later. Okay? We're going to be using our calculators more and more. So let's just jump straight to 10. If sine theta is 1/3 and the angle is in quadrant 2, find the tangent. Okay? That's easy enough. So that tells me my angle is in the second quadrant. My sine is 1/3, so that gives me 1. My hypotenuse is 3 because sine is opposite over hypotenuse. So I need to find this part, which I know is going to be negative because it's in the second quadrant. So I have 1 squared plus b squared equals 3 squared. B squared equals 9 minus 1, so that's 8. So b equals 2 root 2, and I know it's in the second quadrant, so it's going to be negative. It's asking me to find the tangent of theta. So tangent of theta is opposite 1 over adjacent, negative 2 root 2. Rationalize this, I get root 2 over negative 4. There we go. That's some of the stuff that we covered just today. So 11. In which quadrant is sine positive and tangent negative? So let's see. If I drew out first, second, third, and fourth, I know my x is positive here, y is positive, x is negative, y is positive, negative, 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 positive, negative. I want to know where sine is positive, so I want to know either here or here, first or second, and tangent is negative. So I want y divided by x to be negative, so I'm in the second quadrant. The last ones that are on here are all about graphing. So what we have to find all of our necessary details. So my amplitude is 3. My period for sine and cosine is 2 pi over b. So this is 2 pi over 2, which is pi. There's no phase shift here. There's no vertical shift. So my highest point is going to be 1, 2, 3. My lowest point is 1, 2, 3. My end point is going to be pi. We go halfway there. That's pi over 2. Half of that is pi over 4. Ignore that negative. Add these two together, you get 3 pi over 4. Now we look at this number in front. That's negative 3. So we're going to start at negative 3. Then we're going to walk our way up, 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 go back down. And I will only be asking you to graph one revolution. So there we go. Next up, tangent of x plus 1. So I know my amplitude is 1. My period is, for tangent and cotangent, is pi over b. So this is just pi. And I have a vertical shift of up 1. So with tangent starts at the origin. But in this case, if we're moving up 1, our point is going to be at 1, 0, or 0, 1. I go half of my period to the right, so I go over to pi over 2. I go to the left half of my period, so negative pi over 2. I get vertical asymptote there. I get a vertical asymptote here. If I go halfway in between, on either side, I will be up or down 1. So at pi over 4, I'm going to be up. At negative pi over 4, I'm going to be down. And then tangent looks like that. All right, that takes care of the second page. I'll see you on the third one. So here we've got more graphing with phase shifts, vertical shifts, and the like. So 14, amplitude is 1. My period is pi over 1/4. So that's pi times 4, which is 4 pi. My phase shift is negative c over b. So that's negative pi over 2 divided by 1/4. So I flip that guy and multiply, so that's negative 4 pi over 2, which is negative 2 pi. Okay. The last bit and this is just my suggestion, where I'm going to write out my vertical asymptotes. I normally have one at 0 and at pi, but I'm going to subtract. So I normally have one at 0 and pi. My period is 4 pi, so I should have one at 0 and 4 pi, normally. That's given my period. And I'm going to add the phase shift to each. So I'm going to take away 2 pi, take away 2 pi. So instead of starting at 0, I'm going to start at negative 2 pi. So there's negative 2 pi. I'm going to have a vertical asymptote right there. Instead of being at 4 pi, I'm going to be at 1, 2 pi to the right. Now, what makes this 0? Normally, if I plugged in pi over 2, I'm going to be at 0. So if I plug in 0, I get cotangent of pi over 2, which is 0. If I plug in halfway in between, so negative pi or at pi, I'm going to be up or down my amplitude. Sorry, if I plug in negative pi, excuse that, yeah, I get a negative, and if I plug in a positive, I'm down here. So if I can draw this smoothly, there is my cotangent graph. Moving on. Sine of 2x minus pi. Sorry for the weird symbols. My amplitude here is 1. My period here is 2 pi over b. So my period is pi. My phase shift is negative c over b, which is pi over 2. And that's to the right. So I start at my phase shift, which is pi over 2. And I finish at my phase shift plus my period. So that's pi over 2 plus pi, which turns out to be 3 pi over 2. So now, draw my graph. My endpoint is 3 pi over 2. My starting point is pi over 2. Halfway in between these two is pi, which is nice. Halfway in between pi over 2 and pi is 3 pi over 4. Halfway between pi and 3 pi over 2 is 5 pi over 4. Sine starts at the origin, so we're going to start at 0. Our amplitude is 1, so we go up or down 1. So at 3 pi over 4, I go up, then down, and back up. So there's my sine graph. Next up, negative cosecant. So this is just like 1 over sine, negative 1 over sine. So amplitude is 1, and I'm just going to write this in. It's flipped, just to help me remember. My period is 2 pi over b, so that's just 2 pi. I don't have any vertical shifts, and I don't have any phase shifts, so that's pretty nice. So I'm going to take my cosecant, stretch it out a little bit. I'm going to go to the right, 2 pi. I'm going to go to the left, negative 2 pi. Halfway, pi, negative pi. Halfway, pi over 2, 3 pi over 2, negative 3 pi over 2, negative pi over 2. My amplitude is 1, so I go up and down 1. This is just like a sine, so I get my normal sine points here. And I'm just going to extend it out, walk it the other way. I'm going to do a little dashed graph for my invisible sine. And then in a different color, wherever this is 0, I'm going to get a vertical asymptote. So here are my vertical asymptotes. And hopefully you saw the mistake that I made right away is all of these should be flipped. Why? Because I said it was flipped to begin with. So, little mistake for Mr. Swenson. Let's flip all of our points. And this might be a little confusing. I'm going to do this in blue. Here is our flipped. It doesn't change any of our asymptotes. So, it might be hard to tell, but my graph is going to live below and above my blue graph. So just like me, you can easily make a mistake. You have to be super aware of all of the information you're given. So last up, y equals secant of x plus pi over 2 minus 1. So this has amplitude of 1. That's nice. I've got a period of 2 pi, because that's 2 pi over b. I've got a phase shift of negative pi over 2. And I've got a vertical shift of down 1. So normally, secant is 1 over cosine. Normally, I would start at the origin. So now I'm going to start at negative pi over 2. I would finish at 2 pi. So I'm going to finish at 2 pi minus pi over 2, which is 3 pi over 2. So I'm going to draw my graph in here. So let's graph this cosine. So I'm going to start at negative pi over 2. I'm going to finish at 3 pi over 2. My high and low point is 1. Halfway in between, if I add these two and divide by 2, negative pi over 2 plus 3 pi over 2 is pi. Cut that in half, I get pi over 2. If I cut these two in half, I get 0. If I cut these two in half, I get pi. This is a cosine, and we said we moved it down 1. So instead of being at 1 and negative 1, I'm going to start down 1. So at negative pi over 2, I'm going to start at my amplitude. So here, my high point, my low point, then I'm going to go down, and then I'm going to walk myself right back up. So here is my cosine. And where are my asymptotes going to be? My asymptotes are going to be where it was going to be 0. Sorry, ignore this one. We have one here, we have one here, we're going to have one here. And my max is going to be at negative pi over 2. So my graph's going to go up. And my min is going to be right here at pi over 2. And my max will be at 3 pi over 2. So I made a goof on this one, just like I made a goof on these ones. You got to be really careful with what you do. If you are, you'll have no sweat. So make sure that you're good on graphing, you're good on the first stuff, and you should be fine on Friday. All right, good luck. See you tomorrow.